Alrighty, good morning, gang. We are hitting compound interest today, the best type of interest because it pays you money on money that you didn't have originally. Okay, so today we want to be able to use the compound interest recursion and rules to solve compound interest problems. We want to be able to calculate R and find big R, little r bigger in the recurrence relation. Describe why R is 1 plus R over 100. We'll see that. And also write the rules for compound interest equations, use it to solve problems, and use our financial solver, which is a magical little tool on your CAS. So let's jump into it. Okay, so Alan inherits, let's go through the stuff here we need. Alan inherits 35 grand and decides to invest it in an account where he earns interest of 6% per annum compounding monthly. Find R, the percentage interest rate per compounding period. Okay, so what they're talking about here is we've got a rate, an interest rate, but we're also told that it's compounding monthly, and that's super important in compounding problems because it changes how much money you get over the course of a year. So per annum is once a year, but if it's compounding monthly, then we are looking at Alan's rate in terms of 6 divided by 12. So Alan has a compounding interest rate of 0.5%. Okay, so that's how much is applied each month. All right, so that's not a bad thing, even though it's less than normal, less than 6%. That's monthly, so that adds up to 6% over the course of a year. And because it's compounding monthly, it actually adds up to more than that, but we get down to that next year. Okay, next thing we want to be able to do is write down the recurrence relation that can be used to describe the value of his investment. All right, so remember our recurrence relation from a few lessons ago. So V0 is the initial value. The things we've got in here that are common are the R value, okay, and the Vn. Now R for our recurrence relation is 1 plus R, or 1 plus little r. So R is equal to 1 plus R over 100. All right, so for Alan now, he has 1 plus 0.5 over 100, and the plus is there because now we're increasing the money. In other, like reducing balance depreciation, we've had a negative here, but here we've got a positive. So then I go 1 plus, move our decimal point a few spots. So we've got 0.005. So Alan's R value is 1.005. Okay. So to write the recurrence relation in full, we have V0, the first value is $35,000. And Vn plus 1 is equal to 1.005 Vn. Okay, so that's our recurrence relation. Now we can use that to help write our rule. All right, so our rule is this Vn. Now this here, even though I've spread it out, but this is just the same as R, okay? Not the N, just that bit in brackets is R, big R. So we've already found that here, down the bottom there. Okay, so we found that. So it's quite easy to write this rule. So the rule is Vn is equal to 1.005 to the power of n times 35,000 because we know what V0 is. Okay, so they're the key parts to it. So if you need that rule more clearly, it's Vn equals R to the power of n times V0. Right, and we populate everything but the n value there. Now using this rule, use the rule to find the value of the investment after 7 years. Okay. The important thing here is that the 7 years is made up of months. Because his investment is calculated monthly, we need to go, right, the area or the substitution we need to make for n is Vn is equal to 1.005 and n is 7 times 12 times 35,000. Okay, because it's calculated monthly, we need to turn this period into months. So Vn equals 1.005 to the power of 84 by 35,000. Okay. Now that 5 is a bit dodgy there, but you get the point. I'll actually fix that up. I don't like how that looks. Okay. Pen 0, 5. That's better. Okay, go over to our CAS for this now. So we've got 1.005 to the power of 84 multiplied by 35,000. And after that time, Alan has, so his V84 is equal to $53,212.94. Okay, important to note that we're asked to go to the nearest cent here, and most financial work will be in that form as well. Okay, there we have it. So that's working out the balance of an account using compound interest over a period of time. So the keys are change your R value so it reflects the periods. It might be quarters, it might be bi-monthly, it might be monthly, daily, weekly. So that would have to change depending on, so that there is the time period per year. And then plug that, write out your rule and plug in the period of time, months, years, whatever, is for n. Okay, we'll cruise on down now. Alrighty, we're going to use our financial calculator now, in our CAS. So we'll go up to menu and click across. So Karina invested $36,000 in a term deposit, earning, that should be 8.1. I must have hit the slash there instead. 8.1% per annum, compounding monthly. So there we go. We've got our compounding monthly. We're given an annual rate. What's the value of your investment at the end of 5 years? Okay. So what we need here is we're after n. N is the number of periods again, common variable used. So 5 years, 5 times 12 is 60, and you can actually put that in your CAS. We can go 5 times 60, and I can do that, and it gives me 5 times 12, sorry, and gives me 60. So you can put that in if you're not, if you've got a strange multiplication, that's fine. The interest rate is 8.1. We don't have to change that because we'll tell the CAS later that it's compounding monthly. The present value is negative 36,000. It's a negative because we've invested that money into the bank. We've given the money to the bank. Think of it, if the money's going away from you, it's a negative. If it's coming to you, it's a positive. Payment, we're not paying any more into the account, so that's a 0. We want to know the future value. We're going to solve for that. PY is the payments per year, which will always make the same as CY. CY is the compounding periods per year, which is 12. Right, but we're not paying in, so that doesn't really matter this time. And we're going to solve for the future value. Okay, so we're after the future value because it asks what is the investment at X amount of time. Press solve down the bottom here, and we have a future value of $53,901.49. Okay. How much interest did she earn? Okay, the interest earned is simply the principal, which was, or the value of the account, 53,901.49 subtract the principal. Okay, so anything above the 36,000 that was invested first time, 0, anything above that is a is the interest that was made because Carina hasn't invested any more or put any more deposits into the account. So 53,901.49 subtract 36,123. So she's earned $17,901.49 interest. How long would it take the investment to grow to $50,000? Okay, so we can go back to our financial calculator for this. Right there, we've got everything still in there, which is good. Now, what we want to know is, we know we started with 36 going in. We know that we want it to get to $50,000. So we want our account to be worth $50,000. Everything else is the same. There's no payments going in. The compounding periods are the same, but we're going to solve for n because we're after a period of time. So we get rid of that, leave that blank, and solve. And it's going to take 48.83 months. Okay. What we need to think about though here is that we need to round this number, okay, to the closest month. Usually I'll ask you for the closest month, and that's what I'll do here. So or not the closest month, in months. So 48, that rounds up to 49 months. Because at 48 months, we don't have the 50,000, so we have to go up. Even if it was 48.1 months, in 48 months, we don't have the 50,000, so it has to go up to the next whole month, okay? So 49 months to reach $50,000. Okay. Hopefully that's helpful, gang. See you next class. Have a great day, and we'll chat soon.